My dear students, good morning all of you. In the previous class, we discussed acceleration, types of acceleration, and also uniformly accelerated motion. Whenever a body is moving with uniform acceleration, it holds good four equations. One is v is equal to u plus at. Second one is s is equal to ut plus of at square. Third one is v square minus u square is equal to 2as. And fourth one is Sn is equal to u plus a into n minus half. Then, what are the skill questions that may come from these equations of motion that we are going to discuss today? Here, the first question is, you may be asked that the first one is the final velocity. The final velocity of a body traveling with uniform acceleration varies with the distance x as v is equals to root of 196 minus 16x meters per second. Then find the initial velocity and acceleration of the body. This is the point. So, the final velocity of a body traveling with uniform acceleration varies with the distance x as v is equals to root over 196 minus 16x meters per second. Find the initial velocity and acceleration of the body. Then how to solve this question? Here what you are given is, that is, you are given that v is equals to root of 196 minus 16x. Now squaring on both sides, you are going to get v square minus u square. That is, v square is equals to 196 minus 16x. Squaring on both sides. Or v square is equals to 14 whole square plus 2 into minus 8 into x. Can we write? Then you can write this as v square minus 14 whole square is equals to 2 into minus 8 into x. If you observe this equation, it is analogous to v square minus u square is equal to s only. Therefore here it is analogous to v square minus u square is equal to as equation if you observe. Then compare equation 1 and equation 2. If you observe this, u is equals to 4 meters per second. So initial velocity u is equal to 14 meters per second. And whereas this a is analogous to minus 8. So acceleration a is equals to minus 8 meters per second. This is so simple. This is one equation we are using. Comparison of the given equation with the general equation v square minus u square is equals to 2as. And you may be asked another question. That is, the second question is like this. For example, you are given that the distance traveled by a body traveling with uniform acceleration varies with time t as it is given by 0.1s is equals to 2t plus 0.3 t square meters. Find initial velocity and acceleration of body. This is the question. The distance traveled by a body traveling with uniform acceleration varies with the time t as 0.1s is equal to 2t plus 0.3 t square meters. Find the initial velocity and acceleration of the body. Then for this, how to do this? And once it is clear, it is simple that what are given 0.1s, that is given 0.1s is equals to 2t plus 0.3 t square. Divide both sides with 0.1, that s is equal to 2 by 0.1 t plus 0.3 by 0.1 into t square, or s is equals to 20t plus 3t square. This is equation 1. But we know it is analogous to actual ut plus half a square. So this is analogous to ut plus half a t square. That is equation number 2. Therefore, now compare equation 1 and equation 2. Then what you are going to get here? U is equals to 20 meters per second. That is initial velocity. And here half a is equals to 3, which implies a is equal to 6 meters per second square. This is another point. So, this is another model where you can compare the given equation with s is equal to ut plus half a t square. Then, now come to the other one. Is it clear? And now, the third one is you will be given like this. That the distance traveled by a body, in the nth second is Sn is equals to 11.8 plus 0.4 n meters per second. The distance traveled by a body in the nth second is given. Then find the initial velocity and acceleration of body. Find the initial velocity and acceleration of the body. This also we can easily write. First thing, whenever the distance traveled by a body in nth second, it is always given by u plus a into n minus r. But this is not in that form. So, the known equation should be converted in this form. How? That is, it is simple. You can say that we know that Sn is equals to u plus a into n minus half, or Sn is equals to u plus an minus a by 2, or Sn is equals to u minus a by 2 plus an. That is the first equation. Here this is a constant which is independent of time n. This only dependent of n. And therefore what you have given already, the given equation is Sn is equals to 11.8 plus 0.4 n. That is equation number 2. And once you got the idea of this, then now compare equation 1 and equation 2, then a must be equal to 0.4. So acceleration directly we got it. A is equals to 0.4 meters per second square. Then here u minus a by 2 is equals to 11.8, or u minus 0.4 by 2 is 11.8 minus 11.2. So u is equals to, therefore initial velocity u is equals to 12 meters per second, because here u is equals to 11.8 plus 0.2, taking that side. So it is 12 meters per second is the answer. So these are simply general problems which are comparison with the given equations. And how we are going to apply these equations of motion. Suppose you will be given a question like this, a concept, let us assume. A general solution first I will derive so that we can apply to any numerical value. Suppose in that, let us say the concept, a bullet loses 1/nth of its initial velocity while passing through a plank. While passing through a plank, find the number of planks required to stop the bullet. Find the number of planks required to stop the bullet. This is another. Suppose you are given like this. A bullet loses 1/nth of its initial velocity while passing through a plank. Find the number of planks required to stop the bullet. So first fundamental point, if you can observe, to stop the bullet means after passing through several planks, it must come to rest. That means the final velocity should become 0 after passing through several planks. But whenever it passes through one plank, the velocity is decreased by 1/n times that of the initial velocity. And once you got this one, how to solve this problem? Here, first what you have to do is let x be the thickness of each plank. If x be the thickness of each plank, then what you are going to get, tell me? First thing, suppose if you consider this is a wooden plank of thickness x. Now this is moving with a velocity. This is the bullet traveling with a velocity u. Whenever it strikes this, it comes out with a velocity v, which is equals to u minus u by n, because it loses 1 by nth of its initial velocity. Therefore, this you can write this as u into 1 minus 1 by n, which is equals to u into n minus 1 by n. Suppose this is having a thickness x. So, first of all, what you can observe, as the bullet passes through the planks, the velocity goes on decreasing. That means it should travel with uniform retardation or negative acceleration. Therefore, first of all, what is the acceleration? A can be given as, here you know v, u, s. So, the final velocity in terms of distance is known, v square minus u square is equal to 2as. Therefore, A can be written as v square minus u square by 2s, that is 2x. Therefore, A can be given as v square u square into n minus 1 by n whole square minus u square by 2x. And therefore, here A can be written as u square into n minus 1 whole square by n square minus 1 by 2x. Or A is equals to u square by 2x into n square minus 2n plus 1 minus 1 by n square. Plus 1 minus 1 cancelled. Therefore here, this is a plus 2n minus plus 1 minus n square. This n square cancel. Therefore A is equal to u square by 2x into minus of 2n minus 1 by n square. Therefore the acceleration is given by minus of u square by 2x into 2n minus 1 by n square. This is the first equation. That means this moves with retardation, so you are giving negative. Our acceleration will be given as minus of something. Once you got the acceleration, now it is easy for us. So, first what you have to do, consider a plank having a thickness x. Whenever, if u is the initial velocity while coming out, the velocity becomes 1 by decreased by like this, that is u into n minus 1 by. So first we have to calculate the acceleration, because it's a bullet is traveling with uniform acceleration. For any number of lines it's passing through that, in each case the acceleration should be the same. And once you got this one, then what to do? If you can observe, now let capital P be the number of planks required to stop the bullet. To stop the bullet. If that is the case, what becomes the initial velocity? Initial velocity already known as u. Final velocity becomes v1 is equals to 0 after passing through p planks. Acceleration already known. A is equal to minus u square by 2x into 2n minus 1 by n square, and distance covered s1 is equals to x into p, because each plank is having a thickness x. While passing through p planks, its value becomes xp. Again we got the value of u, v, a and s. So we can apply the equation of motion v square minus again. Therefore, we can write v1 square minus u square is 2a s1. That is 0 minus u square is 2 into minus u square by 2x into 2n minus 1 by n square into x into p. Now, If you observe this 2 cancel, this x and x cancel, u square cancel. Therefore 1 is equals to 2n minus 1 by n square into p. Therefore number of planks required p is equals to n square by 2n minus 1. This is the formula. So in this problem we used only one equation of motion, that is v square minus u square is equal to 2as only. Here this is the general formula. If you for any given numerical value of n, straight away you can calculate the number of planks required. That means, for example, is it clear? Then suppose you are given a problem based on this. How simple it is. Suppose you are given, if a bullet loses 1 by 20th of its initial velocity, while passing through a plank one by 20th of its initial velocity while passing through a plank, then find number of planks required to stop the bullet. So the number of planks required to stop the bullet when you are asked, straight away you can get the answer. No need to do entire derivation. Here, what you are given, if you can observe that 1 by n value is given as 1 by 10, which implies n is equals to 20. Therefore, number of planks required is given by the formula p is equals to n square by 2n minus 1. Thus, once you know the formula, you can get the answer in less than 1 minute. Sometimes you require the speed and accuracy by knowing the general solutions here. It is 400 by 40 minus 1, 400 by 39, 10 and 10 by 39. Therefore, 11 planks are required. Why? Because after passing through the 10th plank, while entering into 11th plank only it comes to rest. So this is a fraction which is after 10 planks. So number of planks required to stop the bullet is 11. This is one from model. And next one. Come to the other one. Here, another concept. I think concept 2 maybe. A concept here, that concept is nothing but a general solution. Instead of putting numerical values, we are putting alphabets. Once you got the general formula, in that if you can put the numericals, you can get the answer in less than 1 minute. In some competitive examinations, we require speed and accuracy. In that case, these are all much useful. And the second one, what you are given is, that is, you may be given that a body starts from rest, traveling with uniform acceleration alpha for some distance and then travel with uniform retardation beta for some more distance while coming to rest at another place. While coming to rest at another place. If the maximum velocity attained by the body is capital V, then find the total distance travelled and total time journey. So, this is another important question. If you can observe, a body starts from rest, traveling with uniform acceleration alpha for some distance and then travel with uniform retardation beta for some more distance while coming to rest at another place. If the maximum velocity attained by the body is capital V, then find the total distance travelled and the total time of journey. Suppose you are given like this, then how to solve? It is simple again. Now what you can observe is, suppose it travels between 2 points. Let us say this is A, this is B, this is C. It is started at this point. Initial velocity is 0. While reaching this, suppose if it travels with the acceleration A1 is equal to alpha, travels a distance S1 for a time T1, and thereafter it travels a distance S2 for a time T2 with retardation beta while coming to rest at another place C as V1 is equals to 0. So, it travels from A to B with acceleration. It travels from B to C with retardation. Once you know that, here the other things that we know, U is known, V is known, A is known. If you want time, you can use V is equal to U plus 8. If you want distance, you can use V square minus U square is equal to 2A. So, in this concept, we require two equations of motion. V is equal to U plus 80 to find the time and V square minus U square is 2AS to find the distance. That means here, first I will take while traveling from A to B, what you are going to get, tell me. While traveling from A to B, V is equals to U plus A1 T1. Therefore, V is equals to 0 plus alpha T1. Therefore, T1 is equals to V by alpha. That is the first equation. And the second one, here V square minus U square is equal to 2A1 S1. Therefore, V square minus 0 is 2 alpha S1. Therefore, S1 can be written as V square by 2 alpha, that is second equation. So, while traveling from A to B, T1, time of travel, V by alpha, distance travel, V square by 2 alpha. And thereafter, while traveling from B to C, in that case what happened? This becomes initial and this becomes final. So, V1 is equals to V plus A to T2. 0 is equal to V minus beta T2. Therefore, T2 is equals to V by beta is the third equation. Then V1 square minus V square is 2A to S2. That is 0 minus V square is 2 into minus beta into S2. Therefore, S2 is equals to V square by 2 beta. That is equation number. Oh, because this minus minus cancelled, V square by 2 beta is the formula. And once you got it, then for to find time, V is equal to U plus AT used, and for to find out distance, V square minus U 2S is used. So for solving this problem, we got. Therefore, if you can observe this, total time of journey, if you want, it is T is equals to T1 plus T2, V by alpha plus V by beta. V into 1 by alpha plus 1 by beta. This is the time, total time of journey. And thereafter we have total distance traveled. Total distance traveled is given by S is equal to S1 plus S2. That is V square by 2 alpha plus V square by 2 beta. Therefore, S is V square by 2 into 1 by alpha plus 1 by beta. This is the point we have. So, if you know alpha, beta and the maximum velocity, we can easily calculate the time as well as the total distance traveled. Total time of journey, V into 1 by alpha plus 1 by beta. Total distance traveled, V square by 2 into 1 by alpha plus 1 by beta. Is it clear? And once you got the idea of this, you may be given a problem based on this concept. A problem, it will be given like this. A body traveling with uniform, a body starts from rest. Traveling with uniform acceleration. Five by 3 meters per second square for some distance, and then travel with uniform retardation and then travel for some distance and then travel with uniform retardation 5 by 3 meters per second square for some more distance. While coming to rest. 5 by 3 meters per second square for some more distance while coming to rest. If the maximum velocity attained by the body is 90 kmph, that is kilometers per hour, then find the total distance traveled total time of journey. And total time of journey. This is the question, that's what you are given. So, a body starts from rest, traveling with uniform acceleration 5 by 3 meters per second square for some distance, and then travel with uniform retardation 5 by 3 meters per second square for some more distance while coming to rest at another place. While coming to rest at another place. That's what you are given. At another place. If the maximum velocity attained by the body is 90 kmph, then find the total distance traveled and the total time of journey. Once you got it, what to do? Tell me here. The problem is very simple now. You got it. Here, alpha is given as 5 by 3 meters per second square. Retardation beta is also given 5 by 3 meters per second square. Therefore, and V is given as 90 kmph. But this should be converted in terms of meters per second. 1 kilometer per hour is 5 by 18 meters per second. That is 90 into 5 by 18. 18 fives. So this becomes 25 meters per second. Once you got it, then total time of journey. The total time of journey is given by T is equals to V into 1 by alpha plus 1 by beta. That is 25 into 3 by 5 plus 3 by 5. Therefore, T is equals to 25 into 6 by 5. 5 fives, 30. Therefore, the total time of journey is obtained as 30 seconds. Very simple. So, instead of doing all the process, once you know this formula for total time of journey, straight away you can substitute the numerical values in that. And similarly, if you are going to find out total distance traveled, if you want it, then it is given by S is equal to V square by 2 into 1 by alpha plus 1 by beta. That is 25 whole square, 625 by 2 into 3 by 5 plus 3 by 5. That is 625 by 2 into 6 by 5. 5 ones, 2s and 5s. 2 ones and 3s. Therefore, 375 meters is the answer. So this is the advantage. Once if you are able to get a general solution for the unknown quantity, after getting the general solution, it is easy to substitute the numericals, so that the complexity in the calculation gets minimized. This is a very important thing. And thereafter, is it clear? And now, you may be given another question like this, another concept, what you can say. A body traveling with uniform acceleration covers a distance Sm in the nth second, and a distance Sn in the nth second. Assuming that m is greater than n. Is it clear? A body traveling with uniform acceleration covers a distance sm in the mth second and a distance sn in the nth second where m is greater than n. Find the acceleration of the body. Suppose you are asked like this, then what to do? This is simply nothing but the distance traveled by a body in the nth second only. Now the solution for this problem is again very easy. The solution for this is distance traveled in nth second is given by Sm is equal to u plus a into m minus half. Similarly, distance traveled in nth second, if you are asked to find out, Sn is equals to u plus a into n minus half. Now, 1 minus 2. Equation 1 minus equation 2. If you do it, that is Sm minus Sn, then u plus a into m minus half minus u minus a into n minus half. Very simple. These two gets cancelled. Therefore, Sm minus Sn is equals to a into m minus half minus n plus half. Therefore, Sm minus Sn is equals to a into m minus n. Therefore, the acceleration is given by a is equals to, the acceleration a is equals to Sm minus Sn by m minus. Sm minus Sn by m minus n is the formula. How simple. This is the problem related to this. So once you know that, so distance traveled in nth second, distance traveled in nth second, subtracting these two, you are going to get a is equal to Sm minus Sn by m minus n when m greater than m. For example, if n greater than m, Sn minus Sm by n minus m. Like that we can take. So for this, suppose you are given a problem. A problem based on that, it is given that what you can give, that is a body traveling with uniform acceleration covers a distance 28 meters in the 5th second and 32 meters in the 7th second. Find initial velocity and acceleration of the body. Find the initial velocity and acceleration of the body. Is the question clear here? A body traveling with uniform acceleration covers a distance of 28 meters in the 5th second and 32 meters in the 7th second. Find the initial velocity and acceleration of the body. Here, if you can observe, the solution is simple. what you are given, if you can observe, when m is equal to 5 seconds, then Sm is equals to 28 meters. And when n is equals to 7 seconds, then Sn is equals to 32 meters. So here if you can observe, n value is greater than m. Therefore, acceleration, straight away you can calculate a is equals to Sn minus Sm by n minus m, since n greater than m. Therefore, a is equals to 32 minus 28 by 7 minus 5. 4 by 2, that is 2. So, a is equal to 2 meters per second square. And now you are asked to calculate the initial velocity. Then also we can do it. So, if you write Sm, it is u plus a into m minus half. But Sm is 28, u plus a2, 5 minus 1 by 2. So 28 is u plus 2 into 9 by 2 only, cancel. Therefore 28 is u plus 9, therefore initial velocity u is equal to 28 minus 9, 19. So 19 meters per second. So directly you got the answer. First you can easily calculate the acceleration, and after that you can calculate the initial velocity, so that you can save some time by knowing the general solutions. And you may be given another concept. Here this is equation of motion, which is simply nothing but you may be given another concept like this. That is what you can say in this case. Here a train traveling with uniform acceleration covers, will travel with uniform acceleration, crosses an electric pole, crosses an electric pole with the velocities u and v respectively. A train traveling with uniform acceleration crosses an electric pole with the velocities u and v respectively. Then find the velocity of train when its midpoint, when the midpoint of train crosses the electric pole. This is the question again. So, a train traveling with uniform acceleration crosses an electric pole with the velocities u and v respectively. Then find the velocity of the train when the midpoint of the train crosses the electric pole. Here what to do in this particular case? In this case, you can write that. First of all, here, what we have to do is let L be the length of train. That's first we have to assume. For example, if you consider generally, whenever you consider train, there exists some coaches, engine, as well as the guard. Just for a convenience to understand in a better manner, this is what you are given. Like that, let us say this is the engine and this is the guard, and these are all the coaches. So suppose if this total length is L, so this is the midpoint I am assuming. Here there exists an electric pole. Okay, this is the electric pole we have. Let us say this is the electric pole. Just for a better understanding, we can take like this. So this is the midpoint P. Then from here to here, this distance must be L by 2. And again from here to here, this distance must be L by 2. Throughout the journey, it is smooth and accelerate. While engine is crossing, the velocity is U. While guard is crossing, the velocity is V. And when the midpoint is crossing, the velocity is V1. So, for engine to this point P, when you consider this is initial velocity and this is final velocity. From P to G, when you consider this is initial velocity and this is final velocity. You know V, U, A and S. So we can use equations of motion, which is V square minus U square is equals to 2AS. That is here between the points E and P. If you consider these two are the points, then V1 square minus U square is 2A into L by 2 is the first equation. And thereafter, between the points P and G, between the points P and G, this becomes initial and this becomes final. So V square minus V1 square is equals to 2A into L by 2. If you observe this, this is 2A into L by 2, this is 2. So, if these two are equal, these two must be equal. So, compare equation 1 and equation 2. Then V1 square minus U square is V square minus V1 square. So 2V1 square is U square plus V square, or V1 square is U square plus V square by 2, or V1 is root over U square plus V square by 2. So if you know the velocity of the train while crossing the electric pole, or U and V, the velocity of the train when its midpoint crosses the electric pole is given by root over U square plus V square by 2. This is simple. And here, once you know this, for any given numerical values, you may be given again a problem based on this concept. You will be given a train traveling with uniform acceleration crosses an electric pole. Uniform acceleration crosses an electric pole with the velocities 20 meters, 30 meters per second and 40 meters per second respectively. 20 minutes per second and 40 minutes per second respectively. Find the velocity of train when its midpoint crosses electric pole. When its midpoint crosses electric 4. In that case, what to do? A train traveling with uniform acceleration crosses an electric pole with the velocity 30 meters per second and 40 meters per second respectively. Find the velocity of the train when its midpoint crosses the electric pole. So already we know that. Here u is given as 30 meters per second and v is given as 40 meters per second. Therefore, velocity of train v1 is given the root of u square plus v square by 2, root of 900 plus 1600 by 2, root of 2500 by 2. Therefore v1 is 50 by root 2, which implies v1 is 25 root 2 meters per second. So, like this, we can do as many number of problems as we can using these 4 equations of motion whenever the body is traveling with uniform acceleration. Thousands of problems we can do it. So, this is how we have to apply the equations of motion in numericals. Okay? Like this. So, you can do some more models in the form of assignment. Okay. Hope you understood everything well. So thank you very much. Tomorrow we'll continue with some other topic, that is acceleration due to gravity. Okay, thank you.